Thank you for joining today's DeepSense Discovery session with CIOOS. We're really happy to have three great presenters here. We have Kelly, Lydia, and Beth, and Jeff. I don't know where I was making up names for Jeff. Are joining us today from CIOOS. And we're going to hear a lot about how to pronounce CIOOS, I'm sure. I feel like that might be one key takeaway that we're going to have from today. But we're going to hand this over, and if you would like to stick to the end, and if you're curious about what DeepSense is, then please stick around, and at the very end we'll give a quick overview of what DeepSense is and how we can help support any of your data type problems and challenges in the ocean sector. So take it away.
Thanks, Jennifer, and hi and welcome to everybody. Thanks for coming to the Canadian Integrated Ocean Observing, or CIOOS, Jen nailed it, presentation, where we'll also be discussing CIOOS Atlantic for the DeepSense Discovery webinar. Here today with us, as Jennifer has mentioned, is Jeff Cullis, CIOOS Atlantic's Technical Director, as well as Kelly Santos and myself, Lydia Ross, CIOOS Atlantic Engagement Specialists. We will be turning off our cameras throughout the presentation to help you stay focused on this interesting content, but here we are, so you kind of have a face to the name when you reach out to us in the future. As Jen mentioned, if you have any questions throughout the presentation, feel free to drop them into the Q&A box, not the chat box, and we'll try to answer them as we go if it's a matter of clarifying something we've said, or alternatively, we'll wait till the end of the presentation to do a Q&A session. So without any further delay, I'm going to stop my video. And yes, next slide. Thanks. Sorry, previous slide. We're just doing a test where Jeff is our slide master. Thank you, Technical Director. So to set the stage for why we're here today, a healthy and safe ocean is essential to our survival and for many, our way of life. The ocean provides the oxygen for every second breath we take and plays an increasingly important role in sustaining food security and economic opportunities through tourism, mariculture, marine energy, just to name a few. Over half of the world's population live near the coast, with tons of coastal communities that rely on ocean resources for their economic, physical, and social well-being. But as we all know, the environment and ocean conditions are changing from an increase in human pressures from things like resource extraction, transportation, coastal development, and anthropogenic climate change. Important parameters like temperature, salinity gradients, currents, oxygen, nutrients, and sea height must continually be monitored to determine the rates at which these conditions are changing locally. We are entering the UN Decade of Ocean Science for Sustainable Development. The science and innovation community are being called on to overcome the challenges faced by our oceans to safeguard a sustainable future for the ocean and the life it supports, such as our own. But how do we rise to this great challenge? Researchers require access to quality, reliable data and information to determine the state of our ocean environment and to help us respond to these complex changes. You might not see it this way yet, but ocean data are a valuable digital resource, often costly to collect, yet priceless and unobtainable after the fact. For this reason, it's so important that the data we collect today be properly managed so that researchers of tomorrow can reuse that information to create a more comprehensive picture of our oceans. Lots of organizations around Canada are collecting ocean data, but with data scattered across hard drives, repositories, filing cabinets, and even notebooks, we need a nationally coordinated ocean observing system to unite these ocean data and make them accessible through a single, powerful platform. Next slide. Today's presentation has already covered why we're here, but we'll also go into an overview of data management, the fair way, an introduction to CIOOS and CIOOS Atlantic. We'll walk you through a website demo and offer some future opportunities. One thing we're learning is that it's not enough just to have ocean data. Data is only as useful as the data management approaches that support it. Next slide.
Thanks, Lydia. With advances in technology, we are very quickly transitioning from a time of data scarcity where data was considered to be too valuable to openly share, to a time of data plenty, where the information being collected is now more valuable as a collaborative tool. So these advances give us the ability to collect incredible amounts of data in real or near real time on what's happening in and on our oceans, allowing ocean scientists and managers to make more informed operational decisions. From sustainable fisheries to the safe navigation of shipping lanes to environmental modeling, data is what provides us with a comprehensive picture of what's happening in our marine ecosystems. When looking at the bigger picture of broader ocean data across Canada, there are vast amounts of data that are being collected across multiple marine sectors for project-based work, for operational monitoring, regulatory requirements, and operational decisions. However, as Lydia mentioned, much of it is used in isolation or it's used for a very limited time. This data is often used by the source organization, and then it's shelved or stored with limited ability for this information to be discovered and reused by others. This often results in a duplication of efforts and inefficient use of resources, simply because of a lack of awareness that the data sets that you need are already out there. Ultimately, this diminishes the long-term value of this information, which, again, as Lydia mentioned, in many cases, it's very costly to collect. In today's digital economy, data is a kind of capital. It's a powerful collaborative tool, but it's only valuable if it's effectively managed so that it can be discovered, accessed, and reused for future endeavors through platforms like CIOOS. Next slide. So what do we mean when we talk about effective data management or effectively managing our data? So research data management is simply the system of practices, procedures, and standards that you develop and implement as a part of your research program or project to maximize the value of the data you're collecting as an essential resource. Before the collection of data for any initiative, researchers, scientists, and ocean managers need to consider how they will store, process, and quality control or standardize their data in order to ensure that this information can be both accessed and shared with your colleagues both now and in the future. So some of the areas to consider include what types of data will you be collecting or will your project work generate? What formats and metadata do you expect to employ? How will this data be managed throughout its life cycle? And how and when will the data be made available to others? Are there any special considerations that impact your data management plan, such as confidentiality or maybe ethics approvals or ethics considerations? Ultimately, all of these factors result in the development of data practices that will greatly increase the value of the information that you're collecting. Next slide. So why is this important? Particularly for the students in the audience, why are good data management practices important? So for many of you who are currently collecting data for project work or for your studies, the obvious benefit is effectively managing information is the completion of the project that you're currently working on. However, there are a number of additional ways that your efforts contribute to a greater body of knowledge. One of them is quality research. So by developing a strategy for the quality collection, processing, and storing of your data, this will ensure quality research results. Good research needs good data. And comprehensive research data management is an essential part of good research practice. It's also a key part of collaborative research practice. So incorporating best practices when working with data will ensure others can easily access this information and share it across your project team or with other initiatives. You're also contributing to your field. So you may not think that the data that you're currently working with, say on capelin populations in Lake Melville in Labrador, or salinity levels in the Gulf of St. Lawrence, or wave heights at the Hibernia oil field off the coast of Newfoundland are particularly relevant to anyone but you and your project team. But in order to paint a comprehensive picture of what's happening in our oceans, a wide variety of data is needed, both current and historical, in order to develop robust models that can be used to understand both what's happening today and also predict what we can expect to happen in the future. So by collecting and storing and standardizing your data in a way that ensures it's interoperable with other systems and other work, your work is contributing to a much broader body of work than just your own. And finally, you're meeting obligations to funders. So data is a valuable resource. And because of this, It's becoming standard practice for funding agencies to require researchers to incorporate a clearly defined research data management plan to ensure data is ethically collected, effectively archived, and can be accessed and used for future research. So for the students in the audience in particular, you're the ocean scientists and researchers and managers of tomorrow, and developing solid data management practices early in your academic or research careers will have tremendous benefit, not only for your own work, but also for the work of others. Next slide. An important resource or set of guiding principles to consider as a part of data management and stewardship that are relevant to all stakeholders in today's digital economy are the FAIR data principles. So these are a set of principles that make data findable, accessible, interoperable, and reusable. So you want your data to be findable or discoverable. The value of data can only be extended if it's findable or discoverable to other ocean scientists or other ocean stakeholders. As Lydia will discuss in more detail, CIOOS has been developed as an open data platform in order to maximize the availability of information on our oceans. This may not always be possible or practical for a variety of different reasons. Perhaps data is being collected for ongoing research, or perhaps there's intellectual property ramifications. But there are ways to make your data findable by others, and CIOOS is currently exploring ways to work with stakeholders to make data discoverable at a metadata level in order to facilitate connections between data users. By ensuring your data can be discovered, data becomes a collaborative tool that can connect you to potential partners. You also want to make sure that your data is accessible. So by ensuring data can be accessed by other stakeholders, or in order to ensure that it can be accessed by other stakeholders, this involves proper processing, standardizing, and archiving of your information so that it can be made available through data platforms like CIOOS. There are a number of platforms for making data available, many of which are discipline specific, but it's very important that data is quality controlled or standardized to ensure that it's interoperable between systems to facilitate the exchange of information. CIOOS has been developed using standards that are recognizable nationally and internationally to facilitate the greater exchange of information. And ultimately, all of these things contribute to data, the data being reusable. So extending that long-term value of data. So by providing a mechanism that makes data available for multiple uses, this reduces the duplication of effort and it improves efficiencies. So rather than collecting similar data sets multiple times, we can identify the gaps and we can work to address these gaps for a more complete picture of our ocean. So these principles are relevant to all stakeholders in the oceans data community, and they can be adopted by data users and data providers to promote the maximum use of data. CIOOS has been developed with careful consideration of these principles in order to facilitate timely access to and sharing of information. I'm going to hand things back over to my colleague Lydia, and she's going to provide an overview of how CIOOS can be used as an effective resource to effectively manage your data. Next slide.
Thanks, Kelly. So to operationalize the FAIR data principles, CIOOS provides an online open data platform for sharing, discovering, and accessing oceans of data. CIOOS is Canada's first ever nationally coordinated ocean observing system with regional associations covering marine observations from the Pacific, the Gulf of St. Lawrence, and the Atlantic. CIOOS is committed to empowering human capacity for ocean observations by delivering a multi-sector observing system for the benefit of all Canadians. But this cannot be done alone. CIOOS is working to foster partnerships across the scientific and end user communities, Indigenous and non-Indigenous governments, private sector, and the public who are working together towards making our oceans better understood. Important partners in CIOOS include financial support by Fisheries and Oceans Canada and the Marine Environmental Observation Prediction and Response Network, or MEOPAR. Operationally, CIOOS is a consortium of partner institutions that comprise each regional association, or RA. On the West Coast, CIOOS Pacific RA partners include Ocean Networks Canada, the Tula Foundation, and Hakai Institute. The CIOOS the St. Lawrence RA is led by the St. Lawrence Global Observatory, or SLGO, while on the East Coast, the Atlantic RA is made up of partners from the Ocean Frontier Institute, Dalhousie University, Memorial University of Newfoundland, Fisheries and Marine Institute of Memorial University of Newfoundland, the Ocean Tracking Network, and the Coastal and Ocean Information Network, or COIN Atlantic. For this reason, regional data that is integrated onto CIOOS gains national visibility. CIOOS has further aligned its platform with that of the Global Ocean Observing System, or GOOS, a program of the Intergovernmental Oceanographic Commission, IOC, of the United Nations Educational, Scientific, and Cultural Organization, or UNESCO. GOOS is responsible for coordinating in situ ocean observation and meteorological networks, data management, and other services around the world. In order to create a system that truly benefits all Canadians, our work respects the principle of aha hanua, a formal recognition by the ocean observing community of the traditional knowledge of Indigenous peoples possess as being uniquely different from Western science. The platform and its data are also being made available en français. Next slide, please. Long-term ocean observations allow us to better understand climate change and its variability, improve climate and weather forecasting, as well as to help paint a picture of ocean status and potential environmental hazards such as warming oceans. CIOOS currently integrates 6 major parameters called essential ocean variables, or EOVs. Using EOVs is just one way that CIOOS has aligned itself with GOOS. At present, CIOOS EOVs include currents, temperature, oxygen, sea height, nutrients, and salinity. These are essential variables for monitoring ocean health, sort of like taking the ocean's pulse. The real power, however, of monitoring EOVs comes from their ability to provide an evidence base for real-time decision-making and help guide adaptive management responses as we navigate towards sustainable development as a region and as a nation. CIOOS is always working to expand its list of EOVs to integrate even more variables onto our ocean platform, such as biological data. Next slide, please. CIOOS Atlantic is the regional association responsible for integrating ocean data onto the CIOOS platform that is collected between Labrador and the US border. As I mentioned earlier, CIOOS Atlantic is made up of a consortium of partners who work together to create an ocean observing system that meets the needs of the local oceanographic communities across Atlantic Canada. CIOOS Atlantic works closely with a multitude of national task teams to ensure your data is effectively integrated onto our platform. By developing an easy-to-follow data management approach, we help to make the ocean data that you collect along the Atlantic seaboard both discoverable and accessible, and where there is an expressed desire by the user community, work to further develop this data into regionally tailored data products. For this reason, the real power of CIOOS is in the partnerships. We see this as a multi-sector pursuit, one that requires the ingenuity of students and the private sector alike to find ways to make their ocean data fair. And this is where CIOOS can help. Next slide. There's a number of benefits related to contributing data onto CIOOS, as well as using the CIOOS platform to access high-quality ocean data from diverse sources. First and foremost, CIOOS is a tool that enables the discovery, access, and visualization of ocean data. Our CIOOS metadata profile, data management resources currently being developed, and our data integration intake form will all help to increase the discoverability of your ocean data. Further, your ocean data will receive regional and national recognition through being visualized on our asset map or searchable in our metadata catalog. In English or in French, we've got your ocean data needs covered. CIOOS aims to serve the needs of an expansive network of ocean observing activities by facilitating knowledge flow between data contributors and users of open ocean data. With so many users of our ocean space, along with sensitive marine ecosystems being harmed by certain human activities, it's important that ocean industries and researchers promote transparency in their work. With ocean data now kept in one spot, the potential for duplicated research effort is reduced, as Kelly mentioned, while increasing the reusability and reproducibility of existing work and opening doors for future collaborations in order to grow that body of knowledge. Our metadata profile is designed not only to make your data interoperable with other ocean data sets across the region, but across the country. Your data citations can increase under our Attribution Data License Agreement, CC BY. With a variety of data transfer and storage services available to data contributors, we have something for everyone's unique capacity to serve their ocean data through CIOOS. And finally, the value of CIOOS for researchers and industry is driven largely by the value of open data. Timely access to open data propels scientific discovery, solutions, and innovation through novel data combinations and the creation of new knowledge from current knowledge. These benefits I've just listed largely apply to many of our user communities beyond researchers and industry, including conservation organizations, indigenous organizations, governments, not-for-profits, the public, and international collaborators. Next slide, please. Kelly, if you're speaking, we can't hear you.
Can you hear me now?
Yeah.
Okay, sorry, technical difficulties. So as we touched on earlier in this presentation, there are a number of benefits to open data. Thanks to rapid technological advances, appreciation of the value of open data, and commitments across sectors to data sharing, the open data movement for ocean observing systems and other communities of practice is growing globally, including within Canada. So in Canada, for example, the federal government released an open government directive in 2014 with the objective to maximize the release of government information and data of business value to support transparency, accountability, citizen engagement, and socioeconomic benefits through reuse. Key commitments in the 2018-2020 National Action Plan on Open Government include increasing the availability and usability of geospatial data through the Federal Geospatial Platform in the Open Maps section of the Open Government Portal. As well, the three federal research funding agencies, the Canadian Institute of Health Research, CIHR, the National Sciences and Engineering Research Council of Canada, NSERC, and the Social Sciences and Humanities Research Council of Canada, SSHRC, or the tri-agencies, have an open access policy on publications and have developed a draft tri-agency research data management policy, which aims to support Canadian research excellence by fostering sound digital data management and data stewardship practices. So how big is the open data movement? The Registry of Research Data Repositories is an open science tool that offers researchers, funding organizations, libraries, and publishers an overview of existing international repositories for research data. And this tool lists close to 2,500 repositories internationally, of which 256 are listed in Canada alone. At this point, if you're a researcher and you want to make your data publicly available, you might be asking yourself, where do I start? In general, data should be submitted to a discipline-specific, community-recognized repository where possible, or to generalist repositories if no suitable community resource is available. Next slide. So what are some of your options that are out there? Some options to consider. Obviously, CIOOS and CIOOS Atlantic. If you're collecting ocean data, even if it doesn't fall neatly into one of the EOVs that was mentioned earlier, by all means, come talk to us. We are completely open to considering what's out there, and we would love to hear from you. OBIS Canada is the Canadian regional node of the International Ocean Biogeographic Information System. OBIS is a global open access data and information clearinghouse on marine biodiversity. It was created by the Census of Marine Life, an international project that spanned 10 years, starting in 2000, and that recorded the diversity, distribution, and abundance of life in the oceans. Fisheries and Oceans Canada is in charge of the management of OBIS Canada, although there are many volunteers, contractors, and organizations that support adding data into the OBIS system. For example, one of our partners, the Ocean Tracking Network. It supports moving data into the OBIS system. OTN is a global aquatic animal tracking, technology, data management, and partnership platform headquartered at Dalhousie University. OTN and its partners are using electronic tags to track more than 200 keystone, commercially important and endangered species worldwide. Another option is the Federated Research Data Repository, often referred to as FERDR. Portage, Compute Canada, and the Canadian Association of Research Libraries are collaborating to provide a scalable federated platform for digital research data management and discovery. FERDR will address a long-standing gap in Canada's research infrastructure by providing a single platform from which research data can be ingested, curated, preserved, discovered, cited, and shared. And a fourth option is Dataverse. Dataverse is a publicly accessible data repository platform open to affiliated researchers to deposit and share research data openly with anyone in the world. Dataverse is free to use, and it's built with open source software. Many universities have their own Dataverse that are available to associated researchers, including Dalhousie, St. Mary's, Memorial University, Cape Breton University, and the University of New Brunswick. It's important to keep in mind that interoperability between these repositories is really what's key. So interoperability, we've referenced that several times in the presentation, is simply the ability of multiple systems with different hardware and software platforms, data structures, and interfaces to exchange data with minimal loss of content and functionality. The diversity of data repositories available causes fragmentation, which makes it difficult for potential data users to find the most relevant data to address a particular question. For example, you might decide the best place for your ocean data is Dataverse, while a colleague of yours decides CIOOS or FERDR is the best option. Adding to the challenge of interoperability is that different repositories have different metadata standards. So for example, the Government of Canada uses ISO 19115. CIOOS has a metadata profile modified from this ISO profile. These standards were selected to ensure interoperability with the national and international ocean data community, including the Global Ocean Observing System that Lydia referenced. OBIS uses Ecological Metadata Language, or EML, as its metadata language. Simply put, these different standards are just different ways to describe the data, including how you would describe the spatial, temporal, taxonomic extent of the data, the research methods and protocols, and the requirements for specific vocabularies. CIOOS is working to collaborate with many of these other data repositories, including FERDR and OBIS Canada, to find ways to increase interoperability between databases so that research data can be used to its full potential. Next slide.
Now let's take a look at the website tour. So over to you, Jeff, and we'll walk through the CIOOS National and CIOOS Atlantic website.
Great, thank you. Hopefully everyone can hear me. So my name is Jeff Cullis. I'm the technical director with CIOOS Atlantic, and just going to go through our website and the CIOOS website in some detail, just to give a demo of how all of this is working in practice so far. So first of all, I'm just going to run through the website from the perspective of a user of CIOOS data, someone who's looking to find data to download. And then second, I might go through a little bit of the steps that will be needed for a data contributor to start contributing data to CIOOS Atlantic specifically. So just to start off with the main CIOOS.ca website, this is the highest level view of all the data. So you start off, there's no data shown yet. There's a couple of different maps you can choose from, some that will show you a little more information about the regions and so on, the OpenStreetMap, or there's a bathymetric / satellite view as well. So initially there's no data, but you can see these 3 buttons at the top that sort of have our categories of the essential ocean variables that can be selected. So there's physical, biogeochemical, and other for some places that have additional variables that so far aren't in CIOOS. So if we click on the physical, you can get a sense of some of those variables that were previously described in this presentation. So temperature, surface height, and so on. There are some additional ones that weren't mentioned there. And then in biogeochemical, again, you have oxygen and you have things like nutrients, nitrate, and so on. So as I say, initially there's no data in here, but at the highest level, if you click temperature, all of a sudden you get some data points across the map. And yeah, I should say these points that show up and also in the right-hand sidebar are the data assets that CIOOS has. So this is referred to as the asset map, showing sort of the high-level view of everything that's all the data sets that are present in the CIOOS system. So yeah, you see now there's 104 different data sets with temperature data. If we were to click, say, surface height, we went from 104 to 115 data sets that are viewable. So it uses an OR-based search, which means that sort of the more variables that you select, the number will either stay the same in terms of total data sets shown, or it will increase. So as we had oxygen there, it just jumped up quite a bit. So it just takes the summation of all those and displays them all in the map and also in the sidebar. So basically, if you were to click one of these points, you can see that it kind of pans over and then to it in the map view. And then on the right-hand side, you get the title, and it sort of expands out to show some of the essential ocean variables that are present in the data set. Then it gives sort of a long-form description of the data set. And then there's also this CCAN link here if you want to get to the data. So I'll talk about that a little bit more in a minute. But and one thing I should note, that you see some data sets that are sort of right in the middle of Canada. Those are not, there's not oceans there, obviously. These are usually a clustering issue where there's one part of the data set on one coast and another on the other coast. So rest assured, it's all ocean data here. So yeah, and then I guess one thing I should mention is that although we see, over 100 data sets in this initial view, none of the data that we're showing here is actually hosted on the CIOOS.ca server. So I think, as Lydia and Kelly had stressed during their presentations, is that we aren't collecting data ourselves, but what we are doing is helping to increase the findability and accessibility of all ocean data within our regions and across the country. So, and essentially what happens is, so those 3 regional associations that were mentioned, all of the data sets that are held by those associations are federated up to the national portal. So this is, as mentioned, the Pacific, the St. Lawrence Global Observatory, and the Atlantic Regional Associations. And if we were to click this link on the top bar for regions, it gives a little bit of information about those, specifically the exact geographic area that's covered by those regions. So you can get a sense of where these lie within Canada and what's covered in each one. So to go back to the map again. So all of this federation is enabled by the CCAN data catalog, as I mentioned earlier. So if I were to go to the data catalog link here on the top right, this shows that we have 285 data sets in total. And then if I click the organizations tab, you see the 3 regional associations that are responsible for these data sets. Now you can see SLGO and CIOOS Pacific have quite a few more data sets in the Atlantic at the moment. They are pre-existing organizations, so they have many data sets before CIOOS even started. And if you were to click one of these, you can drill down and see a list of the data sets here, or you can go back to the main CIOOS.ca website and zoom in on the region this way, and then show all the assets there. And if we were to click into one, we could then click on the CCAN link for that and drill down and find out that this is actually held by the HACI Institute. I'll go into more detail on this interface a little later on. So, and then you can, so that's the Pacific region served by HACI. Then we can go and zoom in on the Gulf Similarly, we could do the same thing, click on one of those points and find out where that data set came from through the St. Lawrence Global Observatory. Finally, just zooming in on the Atlantic region here. So you see the lobster claw in the bottom left of Nova Scotia, with New Brunswick west of that, and the smaller island PEI just north, with the much larger island Newfoundland on the top right. And if we were to zoom in on the southwest corner of Newfoundland here, we'd see the Port aux Basques data set. And what's interesting is if you were to then in the sidebar there, click on CCAN, you get this fuller information about it. And actually, so here it's attributed to CIOOS Atlantic. And if you click on the external organizations page, now it takes us to CIOOS Atlantic's main website. So now we're at ciosatlantic.ca. And one thing that you'll see is that the colors have changed. We're now with a CIOOS Atlantic theme and orange logo. And another thing you'll notice is when you zoom out of the asset map, you'll see no other data points across the country. So this is where all the data is coming from that's federated up to the national website. So zooming in again here to the to that Port aux Basques area, we again see the same information for that data set as we saw in the national CCAN. And then drilling into that, we now see the CIOOS Atlantic colors for the data catalog, where all of this was federated to the national catalog. And here's where you can get down to some information about Smart Atlantic, the ultimate organization that's responsible for serving this data into CIOOS. So this is an alliance between the Fisheries and Marine Institute, the Center for Applied Ocean Technology, CTEC, and the Institute for Ocean Research Enterprise, IOR in Halifax. And it's supporting operational awareness and safety in the marine environment. So this view sort of gives a sense of all the things that are present in the CIOOS metadata profile that's been developed. And as mentioned, that comes from the ISO 19115 standard. It's based on that. And so here you can scroll down a little bit. You'll see there's information about the license in the metadata that's shown here. The key thing being that this data can be used without restriction. It's open data. We are going to formalize this a little bit and, as mentioned, try and move towards a Creative Commons license that will require attribution. So when you use the data set, you'll have to attribute where it came from. And then scrolling down a bit more, there is this data and resources. So if you were to click this ERDAP data subset form, it would take you to another technology called ERDAP that we're running an ERDAP server. And similarly to how CCAN allows the federation of our metadata, ERDAP allows the federation of our data sets themselves. So this will point to the CIOOS Atlantic ERDAP, which will then point out to the Smart Atlantic ERDAP to actually serve the data. It will allow serving the data in many different common ocean data formats, CSV files, NetCDF files, and many others. And in addition, for large data sets, you can actually choose which specific subcomponents of that data set you want to pull. Maybe you just want to pull a certain type of data out of it, or you just want to pull more recent data or a certain subset of the data. You can do that all within ERDAP interface itself, as well as doing some basic visualizations. I will admit the interface to ERDAP is practical, but we are working on visualizations tools to make it more easy to pull out data that's of interest. Further down here, we have information about the metadata source. So if you're interested, you can pull down the raw sort of ISO standard XML data and really drill into all the metadata that's available in there. Not all of it's reflected in this CCAN view yet. And you can also find another view of where the data set is geographically in the data set extents. And then along with the additional info section, you again see all the different essential ocean variables, CIOOS EOVs that are present here. You can see whether, so this is ongoing, collection of the data is continuing. It's a real-time buoy that's constantly collecting data. Then you can see the point of contact is Smart Bay so this is a Smart Atlantic email address. You can find out the responsible party, which is the Marine Institute of Newfoundland and Labrador. And then you can get some spatial information, the GPS coordinates and so on, the region that's covered, the time extent that was covered, and under Citation Identifier, right now this is fairly simple, but we are going to add a full citation string in there soon so that as you're using data, you'll be able to fully cite very easily the data sets that you've referenced in your work. So one nice thing too about the fact that we're using common tools like CCAN and ERDAP is that they both have extensive APIs, so anyone who's a developer here can easily tap into those to pull down the data programmatically and interact with it and visualize it in whatever tools they're most comfortable with. So yeah, to go back, I guess, now to the CIOOS Atlantic site. So just to give a little more information here. So as you scroll through the main page, you can, explore and contribute data by going to the catalog. You can find out a little bit more about the different benefits and users that were discussed earlier. There's obviously information about all our funding partners there. And in addition, you can go to the About section. I was just going to highlight that if you're interested in knowing more about the variables, there's essential ocean variables can be found there, as well as further information about all our partners are available on the website too. So the last thing I wanted to show briefly was just about how to contribute data. So initially that was all, what things would look like from a data user's perspective. As I say, we are growing at CIOOS Atlantic. We're trying to get more and more data sets into our system. So it would be great if members want to contribute. That would be excellent. So we're working through our process. We're starting to automate components of it, but it really is based around building a relationship with our data contributors. So what we're trying to do is start off where you just essentially give us a data integration form, fill this out with some of your contact information, the types of data that you're interested in contributing, what type of multimedia files you might have, whether you own the data and if you have permission to upload it, how you want to, the data granularity question, maybe you have a cruise with many different samples taken along the cruise. Do you want each sample to have its own metadata record and show up on the map separately, or do you want the entire cruise to be one record? Whether the data is open access, whether it's historical or real-time data, the volume of data, and the formats. And another key thing is whether the data is currently publicly accessible online, which helps us, as we say, we're not hosting data typically, so we're ideally we have somewhere that already exists where you have the data up and available so that we can point to that, and the level of readiness that you have for bringing your spatial data into CIOOS. So once that's submitted, then someone will get back in touch with you from our engagement team and continue the process forward to integrate the data within our system. So that covered most of what I had here. So now I'll just open the presentation back up, and I think Kelly will continue from this point.
Jeff, you're going to put us back onto the presentation.
I'm back on the presentation here. Yeah, I'll just share that.
Great. And well, that's looks different than it did, but luckily that's our last slide. It is our thank you slide.
Formatting issues.
I wonder if it'll we will be, one question was whether the slides will be made available, and we can make these slides available. This slide is simply just a thank you to Jennifer and DeepSense and all the participants who attended here today. It was such a pleasure to introduce to you CIOOS and all the benefits that CIOOS and CIOOS Atlantic can bring to your local oceanographic community. And we've hopefully made taking the first steps to contributing data to CIOOS as easy as completing an online form that's available on our website that Jeff just walked through. And you can access that form by clicking Contribute Data. And so simply complete the form and ideally upload a representative example of your data using the upload button, and a member of the CIOOS Atlantic staff will respond to you in a short and timely manner. We're also looking for your feedback, so we'd love to know what you think of our website or some of the things that you want from your ocean observing system. So don't hesitate to reach out with questions to either Jeff, Kelly, or myself. Our contact information is all listed below, but of course this general info@ciosatlantic.ca is acceptable as well, and so we'll be passing out these slides. Thank you so much on behalf of the staff and team at CIOOS Atlantic and CIOOS in general. We'll take any questions. I noticed there were some questions in the Q&A, but we'll open the floor up for any additional questions. Thank you.
Thank you both, or all three of you. So Lydia and Kelly and Jeff, that was fantastic and very eye-opening for all of us. And I wish I could explain how excited I was about the data piece. So I was just on a call with one of our team members, Jordan, and we were talking about data and consistency in data and data governance and the standards that you need around your metadata. And I thought, oh my goodness, I'm going to have to send this link out afterwards because this is fantastic. It's exactly what we need to have conversations about. There's a couple of different questions here that, yes, thank you about the slides, but one of the questions was, is all of CIOOS's data available to the public? And I think you touched on that, but is there anything that's shared in silo, like a data trust as a format?
So right now it's all publicly available data. There are some restricted data sets elsewhere in the country, so at SLGO and ONC, and they are looking at making the metadata available so that you'd be able to discover that data, but you would then have to contact those organizations to actually get to the data itself. But for the initial phase, for our first year, we've been focused entirely on totally open data with no restrictions at all. So that's what's in there at the moment.
And is there an amount restriction? So if I went to download something, is there any issue with me using a lot of data? Is there any user caps?
So far, we've had no user caps. We haven't had a need for it yet, but we're sort of monitoring how much traffic there is. And I think, you know, we've taken a lot of direction from the United States, like we're based off of their integrated ocean observing system, CIOOS, and they've talked about some scenarios where people have a script that goes wrong and starts trying to download everything every 10 minutes, and some of the measures they've had to take to kind of curb that stuff. But so far, we haven't had too much issue with any of that yet. But we'll be paying attention to it.
It's one of those things that it's a good problem to have in a way too, right? That there's so many people that are downloading data. Now we're building this out and building awareness. And I look forward to the day when you have to put lots of restrictions in place because so many people are accessing. So another question that was asked was around standards. And if organizations have different standards for their data, how do you approach that? What's your solution?
So yeah, we've been trying to, I mean, we've run into many different standards. Luckily, I think as Kelly mentioned, there was the federal government standard uses something based off of the ISO standard that we're using. So, you know, we're having to build mappings between these different standards that are used to map the metadata. So, you know, it's easier when they're using something that's based off international standards, definitely. But in cases where they aren't, like as we're starting to get towards biological data, that's where we have to do a much more exhaustive mapping of each of their metadata records to what that would be in CIOOS. And similarly for the data, it becomes a more difficult exercise. So, you know, and we're willing to do that where there's large providers that can give us a ton of data, then it's worth investing that time. But, you know, for smaller providers, it'll be sort of case by case, and we'll work with them to the extent possible to transform it into our profile. But automating that whole process might be more of a long-term goal, I guess.
Sorry, I just moved. I lost my screen by accident. Sorry. That's great. Now, for any of you, and there's a question too. What kind of people, I mean, backgrounds do you have in your CIOOS team? We didn't really, get into some of that. I mean, we know that Jeff's a data manager, and in terms of your backgrounds and roles, did you guys know a lot already about ocean data as you moved into this role?
I can take this one. We're really fortunate. The team is made up of everyone has a varied background. Like, we have a lot of different strengths to draw on. So I know that Lydia has an environmental science background. Jeff is fantastic with data management. Myself, I come from more of a research administration background, and I've worked a lot with partnerships with the private sector over the last 5 to 7 years. We have communications people on our team. We have people who are absolutely fantastic with the WordPress or the website development piece. We've got a fantastic technical team. We have other individuals on the team who are focused more on the visualization piece. So, I mean, it really is a diverse strength team, and Lydia and Jeff both touched on the partner organizations that are involved. And when you look at the capacity that all of these different organizations bring to the table, we're really fortunate to be able to build on the strengths of all of the work that's been done previously. So we're really in a very fortunate position for a project that's, you know, still fairly new and very much under development.
Fantastic. And because we're all working from home, I have a child emptying the dishwasher because the homework's done. So I apologize if there's noise. I can't shut this down. I need
Sign of the times. Sign of the times.
Really, right?
Yeah.
So I apologize. There's a lot of clamoring. So then there's another question. Do you have a strategy for incorporating traditional ecological knowledge? Are there any pre-existing standards? Lydia.
Well, we certainly don't. There's been no road paved yet, and of course it would differ for every First Nations Inuit community, of course. The place-based knowledge that is unique to that traditional ecological knowledge would be a challenge to, you know, we talk about standardizing processes and getting your data moved through this pipeline, but we'll have to really unlearn a lot of the assumptions that perhaps went into the creation of this system, and try to create a system that is respectfully, I don't want to say integrates, but however it is that we represent traditional ecological knowledge, if that was a possibility, we would need to develop that in close collaboration, obviously, with First Nations partners. This is an early and ongoing process. And so perhaps Kelly has something else to contribute to that response.
I think it's important for everyone to know that Indigenous engagement is a huge priority for what we're doing, particularly where the project is still in such early stages, still very much under development. We have had the opportunity to seek feedback and to consult with a number of Indigenous communities across Atlantic Canada, and will continue to do so going forward, recognizing the fact that traditional ecological knowledge is very unique, and it's very unique between differing communities. So, you know, there's not necessarily a one-size-fits-all approach. I hope you don't mind, Jen, I'm going to take this opportunity to make a little bit of a plug. We've actually secured funding for a bit of a side project to look at exactly this. You know, what are the best practices for incorporating or working with traditional ecological knowledge in a respectful way. And we currently have a job posted for a research assistant through Dalhousie University to do a literature review and an environmental scan on exactly this subject. So if there's anyone in the audience who thinks they may be interested, I'd suggest or strongly encourage you to check out that posting and to take a look at that position. It's an aspect of the project that we're hugely excited about, and just recognizing the fact that it's such a substantial body of knowledge, but we really do want to ensure that we're going about things in the right way.
That sounds fantastic, and I'm happy to hear that that work is happening and there's a clear path to, and assigning someone with some role to help ensure that's not something that's on the side of a desk. It's a priority and that work happens. So that's really great to hear.
Yeah, absolutely.
For one of our next questions, it was an impressive presentation, so thank you. An example, do you have an example of where your data has been used from the perspective of AI and machine learning? And do you know if anyone so far has used, I can share something after, but I'm curious to hear what your answer is.
I'm not aware of anything so far. I mean, other than, I think there's some, maybe, I mean, yeah, there might be some use within DeepSense potentially, I'm not sure, but I think that what we're really focusing on is getting to know our data providers and building visualization tools and analysis tools that really help them get to the core of what their problems are, to really drive their use of our system. And so there's examples where things like aquaculture, I think in the Pacific side, there's a visualization of optimal conditions for shellfish. So it's not just temperature, but also multiple different chemical variables that are of interest, and then mining sort of the scientific literature to see which conditions are most favorable for growth of shellfish and things like that. So there might be an angle for some kind of AI there to help them identify those optimal conditions and improve on that to really get as much as they can out of it. I imagine there would be space for AI and things like quality control. We don't do, there are standards for quality control that are developed in the US, Quartod, and I think they make maybe some use of AI, but I'm sure AI could be really used to help clean and understand improve the quality of the data as well. So yeah, those are a couple of different aspects, but
well, I know one example though that we definitely have used where we had a student who completed a project that was trying to predict data coming off of the smart buoy, the Atlantic smart buoy, and that data is now integrated. And now we have another student who's working on refining and augmenting that model and making it more robust and actionable. So the one thing that was a huge challenge for that student, and a few weeks ago, Chris Whidden, who's on our team, presented the project, and one of the biggest things was finding the data and getting it and trying to download it. And this student had so many challenges, and the excitement we have now, that imagine how much easier it's going to be though to use the data coming off of that buoy now that it's going to be accessed through you guys. So there's some great news stories coming out of that, and we'll be happy to share the story of that one. There's machine learning model that's been built out of it.
Yeah, that's a really neat project there, and it'll be neat to see how well that aligns with what the buoys are showing, and who knows, maybe if the buoy starts malfunctioning and giving bad data, that could be one of the first things to trigger to say, there's a problem out there, so you need to go fix the issue because the AI is telling us this, so that'd be pretty neat.
Absolutely, we're exploring. It's good for a short term, may not be a long-term sustainable opportunity, but definitely good for short-term outages. Okay, there's another question. Do you have an initiative that addresses high school or middle school students or helps teachers?
We don't at this time, but it's definitely something that's on our radar. So we've spent the pilot phase of the project really focusing on development. So a lot of the structure that Jeff highlighted today as far as the system itself, that's really been the focus to date. But broadening our engagement and who we're able to kind of introduce to CIOOS so that they can start to work with data, start to access data. High schools are definitely on our radar going forward. So it's something we're really looking forward to.
That's great, and something I actually hadn't thought of, and I don't know why, but yeah, that's a brilliant idea. Even the visualizations alone that Jeff walked us through are easy to understand, right? So it's something that's tangible that someone can touch and see. I'm trying to see if there's any other questions. Please feel free to post any others, and we will share. We'll find a way to distribute a deck to everyone as well. I'm just going to really quickly show a quick couple slides on DeepSense just in case, but there's a reason why I want to show it. The reason why is we're working on a new program right now, and I'll touch on it in a second. Oops, I'm sharing my slide. Okay. So really fast, DeepSense, we do, and I think sometimes people can get confused and think there's CIOOS and DeepSense, and there's all these different organizations in the ocean sector. Maybe do we need them all? What do they do? What's the difference? The thing that DeepSense does is it helps companies use the data, their own, as well as data that comes off of CIOOS or out of CIOOS. So the beauty of a relationship between these two organizations is they have data and we have ways to use the data differently. So really quickly, DeepSense was created by these great founding partners, ACOA, the province of Nova Scotia, Cove, Ocean Frontier Institute, IBM, and Dalhousie. And we were created to help ocean-related companies and academic researchers complete collaborative projects that focus on artificial intelligence, machine learning, and visualizations. And a lot of companies don't necessarily have the ability to identify where they could use machine learning. Maybe they don't have the expertise and the knowledge and the people. Maybe they don't have the capacity for someone to do some work that's very exploratory in nature. And infrastructure and software can be complex and expensive if you don't do it right. DeepSense, we offer partnering up with students, intelligence students and some of their supervisors. And they're the ones who are going to help guide with some skills, expertise, and knowledge and have capacity to work on a project. And we also bring to the table knowledge to support those students and those researchers. We also have infrastructure at Dow. We have IBM high performance computing infrastructure that we own and operate. And we have loads of software and support that's available, and we keep everything very secure. We have a quick process where we identify opportunities, we pair up companies, we scope out projects, we build out hopefully a machine learning concept, proof of concept, prototype, maybe some functional code, so the company can have something that helps grow their business or makes them more efficient, and a student can understand the opportunities in the ocean sector and walk away having some real talent and experience. So really there are two outcomes. We want to make sure the ocean sector is viable and uses data really well and uses it to its advantage. And we also want to make sure that we have some great tech talent that comes into the ecosystem. But the data readiness project is the thing I wanted to chat about really quickly too. We have a summer program going to help students that might not have co-op and internship opportunities that are available to them. So we want to provide some support to companies. DeepSense will pay for a student to come into the company to help improve some foundational data components. So we had a big talk today talking about why data is so important and having good data structure. And without having some good rules and governance around your data, it's really hard to use it for more complex things. And the goal is to get some students to come and help companies do just that. We want to thank very much to everyone at CIOOS. I'm sure there's loads of people behind the scenes as well who are listening or will listen again and contributed to all of this development. But we are very happy that you joined us, and please feel free to join us for any other DeepSense opportunity. We record them and they're posted online on YouTube, so you can always catch them later if this time doesn't work for you. And with that, thank you so much, Kelly, Lydia, Jeff, really appreciate it. This has been really great. I have learned a lot, and I think everyone else has too, based on the comments that I'm seeing as well. It was very interesting. So thank you so much for your time today.
Oh, thank you.
Great. Yeah, thank you very much.
This was wonderful. Thanks again.